Hello dear students, let's discuss from the fourth question onwards. Already we discussed up to third question, the exercise section. See, the fourth question is two conducting wires of the same material of equal length and equal diameter are first connected in series and then parallel in a circuit across the same potential difference. Note that potential difference is same. The ratio of heat produced in series and parallel combinations would be dash. See here, so the thing given here is we have two wires. These have same dimension. They have equal length, equal cross-sectional area, equal diameter. So they have equal cross-sectional area too. So therefore their resistance will be also same. As they are made from same material also, see there will be a dullness in the video because the atmosphere is so dark. Heavy rains are coming. See, coming back to the point. So we have two wires with resistance R and R. If they are connected in series, what will be their equivalent resistance? R is equal to R plus R, which is equal to 2R, isn't it? If they are connected in parallel, what will be their equivalent resistance? If two same resistors of equal value, if two resistors of equal value are connected in parallel, their equivalent resistance will be the half of their individual resistance, that is R by 2. Is there any doubt? We can do 1 by Rp equal to 1 by R1 plus 1 by R2. Here R1 and R2 are same, so it is 1 by R plus 1 by R, which is equal to 2 by R. So Rp is equal to reciprocal of this, it is 1 by Rp, 2 by R. So Rp is equal to R by 2. Is easy. If anywhere you see two resistors, 100 ohm and 100 ohm, if they are connected in parallel, their equivalent resistance will be 50 ohm, that is the half of individual resistance. Like that here, parallel Rp is equal to R by 2. Okay, fine. Now the point given to us is potential difference is same. V is equal to V in the two cases. Now what is the question is calculate or compare the heat produced. We have an equation for heat, H is equal to I square RT. But I is not given here. So instead of I, we can use V. How can we use V? Instead of I, we can write it as V by R. I is equal to V by R, isn't it? So it is I square, that's why V by R all square into R into T. Now we can cut 1 R or make confusion in you. We can write it as V square by R square. Okay. I square, I is equal to V by R. Therefore, I square is equal to V square by R square. Now, cutting 1 R, we get V square by R into T. H is equal to V square by R into T. Actually, this T is the time. So, if it is in the case of parallel or if it is in the case of series, we never consider time here. So, we can exclude the term time. Okay. In the next step, we can do that. So we have to compare heat produced in the case of series to the heat produced in the case of parallel. Okay, Hs by Hp. See, Hs V square by R into T. As it is in the series, we have to give the value of R. What is the value of R? Rs is equal to 2R. So 2R T divided by Hp, that is heat produced in the case of parallelly connected. V square by R by 2. V square by R by 2 into T. This T get cancelled, V square get cancelled. Okay, fine. Then let us look what are the remaining terms. In the numerator, it's 1 by 2R. The remaining term is 1 by 2R. In the denominator, this 1 by r by 2. What is 1 by r by 2? 1 by r by 2 is equal to 1 by 1. This is equal to 1 by 1 into 2 by r. Taking the reciprocal and multiplying. So the answer is 2 by r. So 1 by r by 2 is equal to 2 by r. So let us write it here, 2 by r. Now how to do this calculation? Again, division of fractions is the multiplication of reciprocal, r by 2. R and R get cancelled. The remaining one is 1 by 4. HS divided by HP is equal to 1 by 4. Therefore, let me write it here. Therefore, HS is to HP is similar to 1 is to 4. So the answer is 1 is to 4. Answer for the fourth question. Hope it is clear. If it's not clear, just watch it one more time. It's very easy. Right. Oh, I missed that page. Now, fifth question. How is a voltmeter connected in a circuit? It's very easy, isn't it? See, in a circuit, always voltmeter is connected in parallel. What about the connection of ammeter? Ammeter is connected in series. If you have an ammeter, we will connect it in series to the any device. But voltmeter is always connected in parallel to the device. See here, it is connected in parallel. So the answer is just you have to write voltmeter is always connected in parallel. Okay, right. Sixth question. A copper wire has diameter 0.5 millimeter. Let me write it here. Diameter of copper wire is equal to 0.5 millimeter, which is equal to, I have to convert it now itself. So radius is equal to 0.25 millimeter. Isn't it? Half of diameter is radius. I have to convert it into meter. 0.25 divided by 1000 meter. How to convert millimeter into meter? First we can convert millimeter into centimeter by dividing by 10. Then centimeter is converted into meter by dividing with 100. So totally, if we divide it by 1000, we can convert directly into meter. Or it is equal to 0.25 into 10 raised to minus 3. This 1000 is 10 raised to 3. So if I take 10 raised to 3 to the numerator, it becomes 10 raised to minus 3. Okay, right. Now, we obtain radius. For what we obtain radius in such a case? For finding area, A is equal to pi r square, which is equal to 3.14 into r square. R square means I have to take the square of this one and this one. Square of 25 is 625. 625. Then, as it consists of two digits after decimal, I have to consider 4 digits after decimal. 0.625 into, what is the square of 10 raised to minus 3? It's 10 raised to minus 6, right? So this much meter square. So area I got, it is 3.14 into 0.0625 into 10 raised to minus 6 meters square. Now coming to the question back. Resistivity is given. Resistivity is equal to 1.6 into 10 raised to minus 8 ohm meter. Right? Okay. Resistance is given. R is equal to 10 ohm. We have to find length. So write like this, length question mark. So we will have a focus, we will have a aim to find the length. Now the equation of R is equal to rho L by A, isn't it? So what will be the equation of length? From this we can make an equation for length. Place it here itself. Take the A to the other side. It becomes R into A. take this rho also to the other side. It is in the numerator, it will be coming to the denominator. So finally we get L equal to RA by rho. RA by rho. Now just substitute the values and do the calculation. L equal to R equal to 10 into area here 3.14 into 0.0625 into 10 raised to minus 6 divided by rho, where is resistivity? Yes, 1.6 into 10 raised to minus 8 ohm. Okay, fine. Now let me take this 10 raised to minus 8 to here. 10 into 3.14 gives 31.4 into 0.0625 into, if I take this 10 raised to minus 8 to the numerator, it will be like this: 10 raised to minus 6 into 10 raised to plus 8. From denominator I am taking to the numerator, so it becomes plus 8 here. What is 10 raised to minus 6 into 10 raised to 8? It is 10 square, 10 raised to 2. So here it's 10 square divided by, the remaining term is 1.6 only, right? Next step. So 10 square means 100. If I multiply this by 100, the point will reach here. So the numerator becomes 3.14 into 6.25 divided by 1.6. So you have to do this calculation. It will take some time. So I am not doing this calculation. I think the answer will be almost done that somewhere. Yes, 122.66 or 67, something like that. You get 122.7 or 122.6. So you will get an answer in this range, and its unit is meter. So that's the answer, length. And there is a sub question also. Don't miss that question. Find the value. How much does the resistance change if diameter is doubled? If the diameter is doubled, what will be the change to the resistance? That means if this value is doubled, that's here. If this R is doubled, what happens if R is doubled? See the equation of R, you can see R equal to rho L by A. And if R is doubled, that is radius is doubled, that means we are taking square, radius square. So doubling and square makes it 4 here. So actually what happens is the later resistance will be 1/4 times of the former resistance. So the resistance is changed into 1/4 times. That happens when we double the diameter. You can do the same calculation, just make the radius as 0.5 millimeter. Now it's the diameter. If the radius is doubled, the diameter now becomes the radius. Okay. Or else we can just double this. What is the double of 0.5 millimeter? That is 1 millimeter. So in the next case, diameter become 1 millimeter and radius equal to 0.5 millimeter, the half of this 0.5 millimeter. Just substitute that value in the equation R equal to rho L by A. So you will get a resistance value. I think it will be something around 2.5. You will get a value around 2.5. So that means the value is changed into 1/4 times. Okay, that's all. So that's about sixth question, isn't it? Sixth question. Now moving to the seventh question. Okay, seventh question. The values of current flowing through a resistor and its potential difference is given. You have to draw graph and find the resistance. So the values that are given is in amperes I, in amperes V, in volts 1.6, 1 volt 3.4, 2.0, 6.7, 3.0, 10.2 and 4.0, 13.2. So these are the values given to you. So what you have to do is you have to draw a graph. Let me try to draw it here, or let me rub it. Okay, the values are with me, so I will be using these values. Okay, fine. Okay. Now the values are let me give 1, 2, 3, 4 in amperes, and in this side let me check how to give. Okay, we can give 2, 4, 6, 8, 10. Is that 10 enough? 12 also. So let it be the values. You have to draw it in with very neatly, then only you will get the answer. Okay, 0.5, 1.6. So let me mark here. It is 1.6 in 0.5. In 1 ampere it's 3.4. 3.4 in 1 ampere. The next one, 2 ampere, it's 0.7. Oh, not 0.7. 6.7. 6.7. Three ampere, 10.2. 10.2 in 3 ampere, and in 4 ampere 13.2, somewhere here. So this is the graph. I joined this point. It's almost a straight line. Then see, now I have to find the slope. How to find the slope? Just consider any 2 points. So for my, okay, 1, 2, 3, 4, it's 13.2. Here one more point is there. Okay, let me consider any 2 points for taking the slope. First point I consider this one, and the next I consider this one. Okay, now make a triangle. So go downwards and draw the line. Name it from here A, B, C. That is the way of taking slope. Slope is equal to AB by BC. Therefore it is, what is AB? A belongs to the point 10.2. 10.2. This is 10.2. B belongs to the point 3.4, I think. Yes, 3.4. 3.4. So what is AB? 10.2 minus 3.4. 10.2 minus 3.4 gives us 6.8. So AB is 6.8. Now BC, what is BC? 1, 2. BC is equal to 2. What is 6.8 by 2? That is 3.44. So if you get any value in between 3.1 and 3.6 or 7, up to that it is right. Okay. It is 3.1 to 3.6. There will be slightly variations. If you take these 2 points, you may feel some slight variations in them. As it is not perfectly a straight line, you may feel some variations in that. So this answer is correct if it is between 3.1 and to 3.6. Okay, that's all about the 7th question. Now moving to the 8th one. Eighth one. When a 12-volt battery is connected across an unknown resistor, there is a current of 2.5 milliampere in the circuit. Find the value of resistance. See, in this 8th question, volt is given, is 12 volt. Then whatever is given, current is given, it is equal to 2.5 milliampere, which is equal to 2.5 into 10 raised to minus 3 ampere. We have to convert milliampere into ampere. Then we have to find R. It's very easy. We have the equation V equal to IR. So R is equal to V by I, which is equal to 12 by 2.5 into 10 raised to minus 3. It's in the denominator. You can take the 10 raised to minus 3 to the numerator. So it becomes R is equal to 12 into 10 raised to 3 divided by 2.5. What is 12 into 10 raised to 3? That is, you can write it as 120 into 10 square also, divided by 2.5. So this time you will get an answer. 120 into 10 square is 120,000. That is 12,000 divided by 2.5. Let me check. I have done the calculation here. The answer will be 4,800 ohm, or you can write it as 4.8 kilo ohm. It's 4,800 ohm. You can write it as 4.8 kilo ohm. So that is the 8th question. Now into the 9th question. A battery of 9 volt is connected in series with the resistors 0.2 ohm, 0.3 ohm, 0.4 ohm, 0.5 ohm and 12 ohm. They are connected in series. So just calculate, add them. That will provide you the total resistance of the circuit. Total potential difference is already given. How much current will pass through the 12 ohm resistor? That is the question. So here you have to add, oh sorry, I forgot the numbers. They are RS is equal to 0.2 plus 0.3 plus 0.4 plus 0.5 plus 12 ohm. 2 plus 3, 5, 5 plus 5, 10. That gives us 1 ohm. 12 plus 12, 13. 13.4 ohm. So RS is equal to 13.4 ohm. Then whatever is given, then potential difference is given. That is equal to 9 volt. 9 volt. I is equal to V by R is the required equation. V is equal to 9 by 13.4. So this will give you an answer of 0.67 ampere. That is 0.66. You will get 0.67 also you will get. That answer is okay. 0.66 or 67. So that is the answer. 0.67 ampere. And this is the total current flowing through the circuit. The same current flows through the 12 ohm resistor also. That is the answer you have to write. current passing through the 12 ohm resistor is equal to 0.67 ampere. Why it is the same current passing through them? When the resistors are connected in series, the total current in the circuit is same. That is the answer. Now 10th question, it's easy question. How many 176 ohm resistors in parallel are required to carry 5 ampere on 220 volt line? So whatever is given is resistance we have to find. We are given with potential difference 220 volt and I is given to us. I is equal to 5 ampere. How to find potential difference? The same method. R is equal to V by I, that is equal to 220 by 5. 220 by 5. So this gives us how much? In 200 there are 45s. In 20 is 5. In 20 is 4. 44 ohm. So the resistance is 44 ohm, and the question is how many 176 resistors are needed. So what happens when we connect two 176 resistors like this? The equivalent resistance will be half of them, isn't it? So it will be half of them. What happens when we connect 3? It will be 1 by 3 of them. What happens if we connect 4? The equivalent resistance will be 1 by 4 of 176. 44 into how much gives us 176? Into 4, isn't it? 6. 1 is remaining. 4 into 4, 6 plus 1, 7. So 4 resistors of 176 when connected in parallel gives us 44 ohms. So the answer is 4. You have to check it. Is it right or not? How you can check it? 1 by Rp is equal to 1 by 176 plus 1 by 176 plus 1 by 176 plus 1 by 176. Now you have to calculate it. You will get 4 by 176. Rp equal to 176 by 4. Taking reciprocal, the answer will be 44 ohm. So we need 4 resistors of 176 ohm connected in parallel. So that is the answer. Now moving to the 11th question. 11th question is that how many, okay, 3 6 ohm resistors are given to you. 6 ohm, 6 ohm, 6 ohm. You have to make 9 ohm using this 6 ohm. What happens if we connect them in series? It will give us 6 plus 6 plus 6, 18. What happens if we connect them in parallel? 6 6 6, it will be converted into 6 by 3. That is only, that gives us 2 ohm. So how can we make 9 ohm from that? See what happens if we connect this parallelly? It gives us 3 ohm. And from this parallel circuit, take a series connection to the next one. So totally it gives 3 ohm plus 6 ohm, which gives 9 ohm, isn't it? So 2 of them is connected parallelly and other is connected in series with them. So it gives us 9 ohm. The second question is to find, to make 4 ohm from this. How to make 4 ohm? See, connect these two. So what happens now? The circuit is changed into 12 ohm connected in parallel with 6 ohm, isn't it? So 1 by Rp give us 1 by 12 plus 1 by 6. We can take the LCM, that is 2 into 2 we can do here, into 2. That becomes 2 by 12. So we can write it as 2 by 12. Totally 1 plus 2 is 3, 3 by 12. 1 by Rp is equal to 3 by 12, or Rp is equal to 12 by 3, which is equal to 4 ohm. So when we connect like this, we can get 4 ohm also. That is the, how many? One, that 11th question. Okay. Now 12th question. Several electric bulbs designed to use on a 220 volt electric volt supply line are rated 10 watt. So the rating of bulb is equal to 220 volt and 10 watt. How many lamps can be connected in parallel with each other across the two wires of 220 volt line in 5 ampere? So here, this is the line, this is our circuit. So what is this resistance that our circuit hold is R equal to V by I, that is equal to 220 by 5, which is equal to 220 volt by 5 ampere, which is equal to 44 ohm, isn't it? R is equal to 44 ohm. And now yes, now the rating of the bulb is given. So here V is given and P is given. P equal to V square by R. There is an equation like that, isn't it? We have equation P equal to VI. If we take I as V by R, we can get this equation. Instead of I, we put V by R. That is V into V, that is V square by R. So we have an equation like this. So now see 220 whole square by R gives us power. Power is equal to 10 watt. What is 220 whole square? 22 into 22 is equal to 40. 484 double 0. 22 into 22. Let me check that. 4. Okay, 484. Yes, it's 484. 484 and 2 zeros also. Divided by, we can take this R to the other side and 10 to here. By 10 is equal to R. So that is 4840. So the resistance of one bulb is 4840. We have to reduce the resistance. How can we reduce the resistance? We can check how many bulbs can be connected in this 44 ohm circuit, that is 220 volt and 5 ampere circuit. So when we connect these in parallel, the resistance will be reduced, isn't it? If we connect two bulbs of the same, the resistance will be reduced to half. So we have to connect as much as possible. How to check for that? Just divide this quantity by 44. Just divide the quantity with 44. I think it's 44. Okay. It's 11 times. 11 times gives us 480, so that is 110. So 110 bulbs can be connected in parallel in this circuit. See, actually the rating of a bulb is given and our circuit quantities are given, that is volt and ampere is given. From that we find the resistance of the circuit. Now by using the rating we find the resistance of single bulb, and now we have to reduce this resistance up to 44. So we are checking how many bulbs can be connected. So we divide the individual resistance with the resistance of the circuit. So that gives us 110. So 110 numbers of bulb can be connected in parallelly in this circuit. That's all about the 9th, 13th or 12th question. Then 13th question is 13th question is, a hot plate of an electric oven connected to 220 volt line has two resistance coil A and B. So A have the resistance of 24 ohm and B have the resistance of 24 ohm. Now volt is given as 220 volt. Potential difference is given to us. Now you have to find the current passing through it when they are connected in separately, in series and in parallel. When they are connected separately, I is equal to V by R. This is the resistance R1. V by R, that is, they are connected separately, so only one of them is connected. So that gives 220 by 24. The answer you can find. Next one, if they are connected in series, I is equal to again V by R, but this time R will become what? They are connected in series, so total of this, adding these two one, will get 220 by 48. 24 plus 24 gives 48. They are connected in series. Next thing, they are connected in parallel. If they are connected in parallel, the resistance become parallel combination of 24 ohm resistors. They are connected parallelly, the resistance become half. How it become half? Because they are same. If two same value resistors are connected parallelly, the equivalent resistance will be half of the individual resistance. So it becomes by 12, 220 by 12. So you have to write the answers here. Let me check what were the answers of 13th question. It's 9.2, 4.6 and 18.3. So these are the answers respectively.